Hello everyone, my name is Berk Erhan Yüksel. In today, we are discussing the answers to experiment 1, which is inductor design. In the first questions, uh, we measure the fill factor by this expression. We use the N and cross-sectional area of one conductor and total window area. As you can see from this formula, fill factor was measured at 144%, which is not logical. Of course, when we look at this expression, we see that is meaningless because, as you can see from your picture, n times a can't be greater than the denominator. This fraction must always be less than 1. Therefore, its percentage can also be maximum 100%, not 144. Therefore, this is meaningless and not logically. If you look at the second question, the measured inductance from the RLC meter is 607 microhenry. In these calculations, we found the winding number 14.7, and then we rounded this number to an integer number, which was 15. If we calculate the inductance value from this equation, we found 616 microhenry because of these roundings. Also, we are working with real world. Therefore, we consider the flux leakage. Because of this flux leakage, the total flux decreased. In this total flux decreased, and the inductance decreased also by this formula. And finally, we can find the inductance value, which is 607 microhenry. In the third question, we use two same inductors, as you can see, which is loosely wrapped, and second one is tightly wrapped. The only difference is the second inductor was more tightly wrapped and taped for a tighter fit in the lab video. And therefore, if we wrap the cable more tightly to the core, the produced flux will also be condensed in the core and will have less loss in terms of leakage loss. Then the leakage flux will be decreased, as you can see, and flux linkage will be increased. Therefore, the inductance value, which you can see, also we see on the panel of RLC meter, is higher than the old one, which is the loosely wrapped. And then we found our inductance value 675 microhenry, which is more higher than the old one. Because of this, leakage flux decreases and increases of the linkage flux because of the tightly wrapped. In the fourth question, we have coupled inductors which have connected in series. The N1 is the winding number of inductor 1, and N2 is the winding number of the inductor 2. If we calculate the equivalent L totals, the mutual inductance have different signs, as you can see, and the plus sign and the minus sign. And since if we connect in series the fluxes of these two inductors in the same direction. However, if we connect in series but reverse the direction, the fluxes of these two inductors in the different direction. Furthermore, the mutual inductance will have minus sign because of these flux directions. Therefore, the inductance of system 1 is much larger than the inductance of the system 2 because of the flux directions and reverse directions.